Hello. We are here. I'm Dr. Emmanuel Markoulakis, and this is my honored guest, distinguished Dr. Weiping Yu, YU. And he's from Florida. He's a very distinguished doctor and researcher, and actually NASA engineer. I will read here his LinkedIn description. Yes. Oh, sorry. So he's actually he has appeared in many also TV and the YouTube interviews. However, this is not an interview here. This is just between fellow researchers, and we will discuss here about the nature of empty space, actually, and the nature of the vacuum, because both I also have to add here that I'm affiliated postdoc, doctor PhD in the university, in the Hellenic Mediterranean University, and I and Dr. Weiping Yu have developed some, let's say, not exactly similar, but very correlated theories about the nature of nothing, if you want. We believe that what we call empty space is actually a medium. And this medium, you could say the old word about it in a general sense, the ether, but this medium is much more deeper than this first 200 years before concept about the ether. This is actually not just a simple medium, but it's a medium from which everything we know, matter and light, consists of. Yes. So yes, and in order to have a theory of everything, we both believe that there must be only one particle, one fundamental particle from which everything consists of. So Dr. Weiping Yu has his Uon particle. He will now briefly explain the concept of his theory. It's a magnetic dipole particle, infinitesimal small, if I'm correct. Yes, and from which everything is constructed. Any matter, light is constructed for this very small particle. So imagine it like a sea of this, or a volume of sand in a beach with each condensed individual small crumbles of sand. This is his core particle, and from which everything consists of. I mean, not just, when I say everything, I mean all the elementary particles, all matter and light. Yes? Yes. So I will now give the stage to undistinguished Dr. Weiping Yu. And again, he's an aerospace technologist, NASA engineer and physicist in Kennedy Space Center in Florida, and the founder of the universal particle Uon theory of everything. He's holding a doctorate in engineering physics, and Dr. Yu has pioneered groundbreaking research in both theoretical and applied physics. So please, Dr. Weiping Yu, the stage is you. You can present, you can share your screen. I propose you share the full screen so we don't have many problems. Yes, and please, if you want to say some words and start your presentation.
Okay. Thank you very much for Emmanuel for your inaugural interview with me. It's an honor to join you. Okay.
You're welcome.
So my name is Weiping Yu. I'm a physicist and currently work at NASA in the United States Kennedy Space Center, and I'm going to present briefly what the Uon theory of everything, what that theory, what's the mystery, what's the discovery of that theory. I want to do briefly. So am I able to present my slides on my side? Okay.
Yes, Dr. Weiping.
Thank you very much. So
I'm set now. I think we're set.
Yes. Okay. So I'm going to zoom out now. So let's go to the first point. The first point is all these monocharged particles do not exist. You know what that means? All these particles are standard model of particle physics particles. So that means everything all the particles in the standard model of particle physics, that's called quantum mechanics model, I'm going to prove them they do not exist. This is a bigger claim, okay? So I will demonstrate why they are not exist. And there's a second point. So this is called the false carrier. So the photon particle, or we call the particle of light. These are the false carrier in the standard model of particle physics. And if you look at the far right stamp, it says does not exist either. So, okay. And then the third one. So if I say all the standard model of physics or all the quantum mechanics, the particles in quantum mechanics do not exist, then what make up the universe? And what I discovered is only one single fundamental particle. I call the universal fundamental particle. I named it as a Uon. U represent the universal, and the particle I use On represent stands for particles. So the Uon means universal fundamental particles.
In Greek, you write on it means entity. So it's universal entity. If you translate it in Greek, the universal entity.
That's even I believe that even better than particles.
It's something like God particle.
Yes. Like so. No, the theme of this subject, right, called God particle. To be simply say, this is the so-called universal fundamental particle. It's just a magnetic dipole, or simply just a little magnetic particle. Okay. That's the only particle. Okay, so because the time of short, so I'm gonna just say, hey, so this is the major results, and so what in the following I will try to demonstrate the first. So why I'm even come out with these particles, because if you study physics long enough, like my friend Emmanuel, okay, you will know something wrong with physics. So that's where I kick started. I said, hey, so we have a problem with the physics, understanding, right, interpreting of the universe, and where it started. So that's the part. And I take a start. I find out that actually the problem is not starting. It's not starting at quantum mechanics and the theory of relativity. Actually, is far ahead before that one. That happens in classical electrodynamics. So, and if we can trace back, the fundamental error started with Coulomb's law. That's 1784. It's 241 years ago. So Coulomb's great French physicist. Okay, is a great physicist, and he discovered this Coulomb law. Simply say, like charge repel, opposite charge attract. That's correct. Okay, no problem with this one. However, my problem with this is the only one. Other than what is so this is the way they presented it. There's a negative charge particle and the positive charge particle carried by two separate particles. So which make this particle as a monocharge particle. Say we have a one particle carrying negative charge particle, eventually we define it as an electron, right? And in the same time, afterwards, people discovered, oh, there's a particle carrying only positive charge. So then started called a proton, or called antiparticle is positron or something. That's the problem. So there's no problem with the like charge repel and the opposite charge attract. No problem. However, this law imply the monocharged particle exists, which that's in the following slide. I try to prove this kind of particle cannot exist anywhere in the universe. Okay, but due to the time constraint, so I just moved to the another second slide on the middle one on the top middle chart.
Dr. Weiping, don't worry about time. Just make your presentation. I can always go, push my schedule further back. So don't worry. Just present your theory, please. Yes.
Thank you, kindness. Oh, generous. Okay, so you've started with Coulomb law, but at that time, all the concept of the charge or particles are very vague.
Dr. Weiping, if you want to go to the next slide, because I just see a preview of all 6 slides, so we can go. Yeah.
You wanted me to show the slides?
Yeah,
okay.
Yeah. So this is now full screen, all the slides. So can you go to the? That's fine. That's great. That's great.
Thank you so much. So the Coulomb's law, everything looks fine, except. Oh, sure. Stop sharing.
Hide.
Okay. Except it assuming the monocharge particle exists. So they said, hey, one particle carries negative charge, another particle carries positive charge. That's the problem I have with this one. So now let's look at what's the real thing. I find how does we call the derailed, the physics truly derailed and run off the course. It's really at the time called the J.J. Thomson discovery of electrons. I know my friend Emmanuel, you know this one, knows right? How significant this fundamental discovery of electron in your electrical engineer major, right? Your physics, but with a specialty in electrical engineering. And
my doctoral is in electrical engineering. Yeah.
Yes. Oh, okay. Wow, wonderful. So you have a multi degrees of cover so many things. That's the point. Everybody believed this was the greatest discovery at the time.
Yes.
Right? 1897 is the end of the 19th century. At the time, we believe all the physics laws already being discovered. We no longer do. But let me tell you, I believe this discovery of electron, especially J.J. Thomson, named the electron as a negative charged particle. That's the part, I'm questioning, right? That's called a monocharged particle. I try to prove that particle does not exist. But however, J.J. Thomson named that particle as a negative charged electron. So
I agree with you, Dr. Weiping Yu. I agree with you. In the beginning, when you have the first discovery, it's very easy to get the wrong turn.
Wow, man!
And when it's like a Jenga. If you do the first Jenga wrong, the whole thing goes like a domino then, and you end up with today's quantum mechanics.
See, no wonder we are resonant with each other. This is the most important part, and you and I agreed. So that means, so I'm gonna just quickly run this video, 20 seconds. Yeah, and then I will explain.
It's just not for us; it's also for our audience. For the to inspire young physicists. Yeah.
Yes.
Play.
Here we can see the electrons being deflected by the magnet. The cathode ray moves upward. If we reverse the magnet, we would predict that the beam would be deflected in the opposite direction. And we observe that the beam is deflected downward.
Okay, I try to say the problem with this discovery, with this called cathode ray test, is this event. You see, the magnets interact with this stream of light. So what happens inside of this vacuum tube? Of course, the vacuum tube filled with some kind of inert gas or some kind of air molecules. Okay, so under the differential of voltage between cathodes and anode, the electrodes, and we have a pressure, we have a voltage differential, right? That create what is ionized the gas particles inside of this tube. So the inner tube or the air molecule, they ionize. What happens when you ionize the molecules? Becomes a charge. And what kind of charge? It really happens is it made the magnetic particles. It make ionized the particle. Those particles actually are made by magnetic particles. So make those particles magnetic particles forming a beam of magnets. So at that condition, then you use magnets underneath to interact with them, either bending upward or bending downward, depends on north and south magnetic pole. So what happens is this is a purely magnetic interaction event. However, this is being interpreted, or called misinterpreted, as a electrical event. So J.J. Thomson said, hey, the particles in the beam of the light, he said, oh, the particles must carry a negative charged particle. And at that time, so he named the electron as a negative charged particle. I believe that's a mistake. But how significant this mistake is. So if you look at the bottom takeaway, it's like you call the interpreting magnetic response as a charge, as an electric charge, and this is a fundamental error. So if you say this is a fundamental error, so if it's not a charge, what's interact? It's a magnet interact with the beam of charged particle, and the beam of a charged particle are made by magnetic particles. So that's why it's a magnetic interact with the magnetic beams. Okay, so let me see if I can come to the next one. The next one try to say why I claim this discovery is actually derailed physics instead of is advanced for physics. So I use a logical concept, say, hey, assuming this discovery is correct, we have a negative charged particle, electron. Assuming that's correct. So what happens if we split the electron? If we split it, we either get three options. Either called both half carry negative charge, or one negative, one positive, or both half carry positive charge. However, all three cases are violated the fundamental laws, okay? So let's just talking about the first one. Assuming electron hypothetical, I'm not called real, just conceptually, because anything you call a physical object, it also made by smaller components, right? Smaller parts. So then I just, hey, let's hypothetically say, hey, electron has a mass, right? Let's hypothetically say split the mass into halves. And what happens? Can you recombine the half as a whole, as an original magnets, original electron? You cannot. If you can't, then it's a contradiction or kind of violation of Coulomb's law. Coulomb's law says large charge repel. Opposite direction. So you have a large to half charge. How can you merge it together? You cannot merge, right? So that means if you cannot make a small component to be a bigger one, what that means? That means the electron, the negative charge particle itself cannot exist in the first place. I'm not gonna go through. So all other cases, either violate the Coulomb's law or violate the charge conservation. Say, can we hypothetically divide the electron to two halves and with one half negative, one half positive? If we can, that means violate the charge conservation. So we have a charge divided by charge. You will, charge always, summation of charge always equals constant.
That's actually an excellent argument you do, proof by contradiction. Yeah, it's very
contradiction of
argument you do. Yeah, contradiction
charge
of the
conservation
law itself. Yeah.
Thank you. So then I'm gonna go because I know. So this one means all outcomes violate the Coulomb's law or charge conservation if electron is a true monocharged particle. This basically demonstrate that it violates the physics laws. If what Coulomb's assuming there's a negative charge particle, or J.J. Thomson say, hey, electron is a negative charge particle. If this happens, it violated conservation laws or Coulomb's law. Okay, so now I'm gonna show you the next one. Let me see. I want to show you all the physical experiments. I believe you may have this plasma ball experiment too, right? You may have this one. If you look at it, if I put my hands on the plasma ball, what do you see? All the filaments,
all in one line. It's aligned.
Yes.
Everything in one line.
All come in one line means they all attract to each other. There are millions or billions of electrons. Why they attract, right? So that's okay. So that's what I try to demonstrate. In any real world experiments, you never see two electrons repel. And now I try to say what's happening. What's happening for electrons? So electron is actually just little magnetic particles. When you see magnetic particles approach each other, either opposite pole attract, or look at it like pole. What happens to like pole attract? It make turns and then attract. So the result is always they attract each other. So now let me display this video.
Exactly. This is also one of my old conclusions, that by preference, magnetism is always an attractive force. By preference, if you leave free the magnet, if you leave it free, it will always attract with the other. It's so
yes.
Magnetic forces by preference always attractive, the same as gravity.
Yes. So you may see the gentleman use the magnets, see the filament rotate, interact with the magnets. The reason is all these four filaments are ionized molecules or atoms, molecules of the gas inside the tube, right? And when the molecules ionize, they become tiny magnets and form a line of magnets. And so that's why you use external magnets, it will interact with you. If you understand this one, then I give you one more example. Say, what about the current physics? Basically I try to say all the electrons on negative charge particle or positive charge, they are magnetic particles. So that means one particle has both negative and positive. So now I demonstrated in the physical world, no matter what you observe, eventually the particles always attract each other. So that demonstrated a magnetic behavior. So now I say, does this violate the current called the standard model of physics? I look at all the particles in the standard model of particle physics, the latest and greatest physics model, all have magnetic moments. What does that mean? That means they all behave like magnets. So there is no contradiction between the Uon.
Even the chargeless one, the one which don't have charge. Like
right. That's a good
moment. Yeah.
Yes. That's a good point. I will tell you. So basically, the so-called Uon theory is basically say, hey, Coulomb's law correct mostly, except they assuming negative charge particle or positive charge particle are separate, as carried by separate charge particle. Uon theory, no, they all come by carried by one particle. It's called a magnetic particle. That's all. So and this page is telling about is there any physical evidence that people ever see electrons. Let me tell you, no one ever see what the electron looks like. We know electron only from 3 plane.
I object, Doctor. I in my presentation, I will show you exactly what the electron shows like.
Oh my goodness, wonderful.
In my presentation, I will show you exactly what the electron looks like.
Okay, so I'm gonna.
You will. I assure you, you will like my answer because it's very close to what you are saying.
Wonderful. No wonder we both come up to the same conclusion. The universe only made by one single fundamental particle. I call the universal particle called the Uon, and you call the Graviton. What do you call the Uon?
I will explain. Yeah, I will explain.
Okay.
Yeah.
Okay. So I'm gonna wrap up this one.
Wonderful presentation. Please finish. Yes. Continue with the wonderful presentation.
Okay. So if I'm right, I said the electron does not exist. People immediately ask, if an electron does not exist, how could we have electricity, right? So I try to say, what's the problem with our understanding of electricity? So if you look at the left side, called the classical electricity model, which defines electricity as a flow of charge. And how could the charge flow? Charge carried by electron, so you can deduct to electricity is a flow of electron. Electrons are particles, right? And that's the one. I think that's I never accepted this concept since my middle school year. We learned electricity. I could never imagine how could the electron is a solid particle in my mind, right? How could a solid particle traveling in a solid conducting wire, in solid wire, at 70% nearly speed of light, right? At 70% of the speed of light. How could that happen? And turns out I found, actually, what we saw as electricity, there's no particle traveling. But what happens if you look at the far right, the side, the Uon theory of electricity model? There's no translation, but it's an oscillation. It's a vibration. It's oscillation particles. The particles in the conducting wire oscillating locally. And what happens? Because the wire is continuous, right? It has a continuous magnetic or called elastic medium. So when you have a local oscillation, and this oscillation translated through this medium, through this wire, the elastic medium, and create what they call the elastic wave, created this called a wave. So wave propagation. So basically, the so-called electricity is not a flow of particle. It is a vibration of the wave motion of particles. Okay, so I wanted to save some time for my friend Emmanuel. So I say, hey, these are, let me finish this side. I'm not going to talking about this one. Okay, so what consequences about this model?
Please take your time, Doctor.
You wanted me to take time?
Present everything. Yes, present everything. I can, for the sake of science, I will cancel my Saturday, outgoing. No problem.
No, okay. Thank you, generosity. I'm saying apologize to your wife first.
Forget the wife now. Yeah. Now the wife is science, is physics. Let's continue.
Is she with
My
you?
wife is physics now. Yeah.
Is she with you now?
Yes. No. I have all the time. Please. There's no more pressure of time. Okay, we can do it in this 2 hours. No problem. I can always go out later on for walk.
Thank you. So then I just wanted to say why I say everything's oscillation of electricity. If you look at all electricity generated, either is a rotating wire in a magnetic field or a fixed coils with rotating magnets. It's all, what happens with this rotation in the magnetic field? Because if you look at the chart on the right hand side, the particles all the particles are magnetic particles, okay? So these particles, when rotated in a magnetic field, what happens? It creates oscillations, right? local oscillation, and this oscillation propagates through the conducting medium. That's create the electricity. So that's the whole page. And then I would say the consequences. The consequences is very significant. If you say we do not have
animation. Very nice animation. I like that one.
Oh, you like that
very
one,
nice
right?
Animation. Yeah, very nice.
Thank you. I like your video demonstrate the gravity video. You know what I mean, right? The video. Okay. So the consequences is if there is no called electrical charge. Oh, I have to say the first mystery is we do not have these things called the electrical charge. The so-called electrical charge is really is a magnetic polarity, is a magnetic pole. So right now we have an electric charge and magnetic pole, but actually the so-called electric is just magnetic polarity. Okay. So now let's say, so that's the first mystery. Okay. So-called electric charge, people know what's the origin of electric charge. Electric charge is a magnetic pole, either positive or negative. Okay. So that's the first mystery. The second one is if we say this kind of magnetic charge, electric charge does not exist, which means electron does not exist. They are all made by magnetic particles. Okay. So what happens with this called what is called orbital atoms? So I believe Emmanuel, you can see the model, right? The orbital, the so-called orbitals means we have electron, negative charge particle orbiting around the center of the nucleus. And if electron does not exist, and the electron just magnets, can magnets orbiting another center of, we said a proton or neutron? And I made this model. If electron is a magnetic particle, and the proton is also magnetic particle, and the neutron also magnetic. I will demonstrate how to make neutral particles with magnetic particles. I explain later on. But you will see if electrons are magnetic particle and the nucleus are also made by magnetic particle, can electron orbiting them? No, magnets will attract to magnets. So that demonstrate. So electron is actually, if electron is a magnet, then it will pull into the nucleus. It cannot orbital. So basically, the meaning is the orbital atomic model collapse under magnetic reality. So that means this model cannot be there. What I find is what made the atom is a smaller magnetic particles, like a neutron, proton, whatever. The magnetic particle comes as a composite particles. Okay, so that's one important conclusion. And the second conclusion, that's one consequences is this perpetual motion atom model, or we call the orbital model, cannot exist. So real atom is so stable because it does not have any parts orbiting any other parts. It's actually just as a whole.
Unless there is a hidden source in the universe, which
Yes.
which refreshes all the time the particles, all this matter refreshes.
Yes.
There's no perpetual motion, but let's assume that for now that there's a possibility that there's a second hidden source of energy.
Of course, if you have a
dynamics, you have a flow of energy that
yes,
keeps up the atom all the time doing its job, something like that.
You got it. The atom would be vibrating.
We can discuss
Yes.
it later. Yeah.
So the so-called not perpetual, it means there's no external energy input, and
Yes. In that sense, I agree. You cannot have
Yes.
perpetual motion.
Yeah.
If it's no external, if it's closed system, you cannot.
Yes. So, Doctor, Emmanuel just mentioned, but if you have an open system, so that's no longer called a perpetual motion machine, right? Open, you have energy exchange. Of course,
Yes.
you would have a vibration motion or some local vibration or some kind of split of atoms or something would happen. Okay, so
agree.
thank you for make audience clear that one. And another I would believe this is a major consequences of this Uon theory of everything. The most important is the quantum mechanics model we call the standard model of particle physics, summarized by this chart. This model is built entirely on this called orbital atomic models. If you look at the center of the graphics, if you look at the center represents the atoms. So, the yellow part, and at the yellow part, there's a core, like blue color something, that represents the center of nucleus. And outside of that core, the yellow regions represent space. That's space where we'll have a residing of electrons, and in different orbits, or in different principal shells, or we now say, hey, we have called the electron clouds or something is occupy those space. These models is all built on this called orbital atomic models. So since the orbital atomic model does not exist, it's fake, it's false. So then the whole condition, whole assumption of this called particle physics, standard model physics, built on the wrong foundation. So I believe this one is fatally flawed. So if you look at quantum mechanics, built on two false assumptions. One is a minimally charged particle.
I'm very pleased with you, Dr. Yu, because you are concerned not just for an effective model, but for what actually is happening, the ontological nature of matter, which is the last 100 years it's forgotten. A physicist, I believe, must be caring about the ontology of. That's the work of a physicist. Explain what is really happening, not just an effective toy model. But no. I want the real thing.
Yes, I know what they mentioned that one too.
Yeah,
I'm
so
happy.
Calculations, but I want also to know the physical reality, what it really looks like. That's my problem with modern mathematical physics, not with mathematical physics. Please continue. Sorry for interrupting.
I just want to make one comment. Your comment for me is so valuable because that's the peers review, right? I'm your peers. I review your model, and your peers review my model, and we come to the same conclusion: the universe made by only one fundamental particle. It's not by dozens of called the quantum mechanical particle. Or if you talk about the supersymmetry, I know you mentioned about it. Supersymmetry model cannot be correct, or string theory. I
don't believe in supersymmetry. They just add more particles. That's not the problem.
They only
reduce the particles.
They only double the particle count, and still cannot solve any problems, right? So.
Yeah. No. The problem is addition. The solution is subtraction, not addition. You have to subtract to reduce, not to increase the thing.
Yes,
I agree with you totally. Yeah. But
yes.
Please continue.
Yes.
Enjoy your presentation. Please.
I hope this is shocking enough to your audience. Okay.
I don't have an audience. Sorry, I'm just alone. I don't know. My channel is not. It's not a regular
right.
channel. I just meet with you. That's all. So if anyone who is interested in this and can see this conversation and like it, no problem. But I don't have an audience. So it's both. It's a common audience. I don't have my particular audience. I'm not a science channel. I'm just a scientist which likes to share ideas with other scientists, and then, if possible, to make this public, this conversation, so other scientists will benefit too.
Thank you.
From thinking out of the box.
Yes. Yeah. Okay. So just say, hey. So after I talking about the quantum mechanics particle cannot exist. Oh, I have not explained the neutral particle. Later on, I either will have that one. So then I'm talking about the second point. The first point is quantum called monocharge particle does not. The second point is photon, the particle of light, does not have either. Okay, so this is the part I try to address why photon does not exist. I may go a little bit faster. So let's see. Whenever come up the concept of light, we have 3 different type of theories. One called light is a wave motion. So the second one is light becomes a particle motion, just like a bullets. Bullets particles travel, which does not rely on medium. But if you're talking about a wave motion, wave require a medium to propagate, right? So that's why, if light is a wave, then wave demanding of a medium, and this medium actually is ether medium. I know, Emmanuel, that you agree with me. We have to have this medium, right? Okay.
Of course.
Yes.
There is a medium. Yeah.
That's what I believe. That's what you call the 0 point vacuum.
Yeah, some kind of vapor, of universal vapor.
Yeah, that's actually is a 0 point vacuum. So-called vacuum is a field with this medium.
It's the lowest possible energy we can find close to 0 Kelvin.
Exactly.
Yeah.
So that's why we have to have a medium, have to have
some
energy.
kind of vibrations persist. They're never going down, even if you go to 0 Kelvin theoretically.
Right.
You will still find this vibration.
Exactly. I agree with you.
It's like water boiling in a pot, you always get this kind of. Okay, please continue.
Okay, so the third theory called the wave-particle duality, this is quantum mechanics theory. And this quantum mechanics, this wave in quantum mechanics, it's not a wave transmitted through medium. This is a purely abstract concept. Oh, wave vibration is massless and was no real medium. So that's something. And I found it is quite strange. This wave particle duality means something, if you look at it, it looks like a particle is collapsed. It's an observer effect. Something looks like a particle. But if not look at it, when they transmit it, you through wave, it becomes a wave, like a behavior, becomes a wave. And this error, I believe this is error, is due to the 2 fundamental experiment I will explain later on. Say one's a double slit experiment and photoelasticity. Why that theory, that experiment misinterpreted. So that's why we come up with this is called the nonsensical conclusion, wave particle duality. So the light, so basically what the light in my definition is a magnetic oscillation, is oscillation, some magnetic particle oscillating, and then propagation, oscillating and propagation through a medium, right? So oscillation through a medium, and the medium cannot be a neutral medium. So I use magnetic medium. I will explain why I use them. This is one example I try to demonstrate. So why light cannot be a particles. So I use this one. Say, hey, if I have a light bulb, use a little battery to lit up a little light bulb, and can everybody see in the auditorium or in the theater? And people say, oh, of course we can see it. And then I ask, so hypothetically, imagine how many particles would needed to be seen by everybody at a different distance, a different angle, right? And a different height. How many particles can be seen by audience all at once? It would require the particles of light fill out every single point in the auditorium. How many points in the auditorium? Will be infinite number of points. So I said, can this little light bulb generate an infinite number of particles to interact with everybody's eye at the same time? I said that this is impossible. So then what? So if this if light cannot be particle, so what's the alternative? So that's where I brought in, say, let's assuming the space is not empty. It's actually filled with this called a medium. This medium is made by magnetic particles, okay, like a magnetic fluids. So fill up with a medium. So now the light just a little disturbance. So the light at the center, just a little vibration. And once you have this vibration, and the vibration then propagates through the medium, propagates everywhere in the auditorium. That's where, after a second, that's where everybody can see light. So I use this one to try to say, hey, if light is a wave needs a medium. So when the space is not empty. So that's the message.
In my presentation, I have exactly the same slide. Well, exactly. It's the same water surface.
Water surface.
Light as a distortion in the medium, in the universal medium.
Wonderful. I love to see your slides.
You will see later on. Yeah.
But today, I probably use up all the time. Oh my goodness. Okay. So there's another called a polarizer experiment. I'm not gonna show this one because I have to stop my slides and may take a while to get back. So basically, I use a polarizer to show, if I line the three polarizers together, you can see through them. If you use a particle concept. However, if you take one away, you just align the two transparency. If I rotate one of them, rotate 90 degrees, your light will be blocked. So this is a fantastic experiment, but I don't want to show here. And what that means, they say, hey, why
yes,
you can...
And I also suggest to anyone of the audience to see you live, to go and watch, to search for your live presentations of this experiment. Okay. Yeah, Dr. Weiping Yu had many presentations live, and in some of his presentations you can find on the internet.
Yes.
He actually presents live this experiment using 3 polarizer filters.
Yes.
And, you can see the trick. When it's 90 degrees, you see nothing. And when it's 45 degrees, in sandwich in between, you can again see it becomes transparent. It's very important demonstration of why light cannot be a particle.
That's right.
Dr. Weiping Yu. So I suggest to all our audience to go and find your live presentations.
Okay. Wonderful. So next time when we connect, we may demonstrate. But for today, so I just say, hey, light behave as a wave, cannot be a stream particle. And this slides, I come out the conclusion. So what happens if light is a wave? What is a wave? I try to explain. Wave requires a medium because a wave is require a medium to propagate. Wave are vibration of medium. I may need to modify this one a little bit. Say light is a wave, and what is a wave? Wave are vibration and propagation, right? So I misrotated this one. And the wave are vibration of the medium. So you have something has to be vibrated, right? That's the medium, the particles in the medium. Just like water particles in this case, Emmanuel, you mentioned about it, you have use water, right? So the medium in this case, you use molecules, in the medium vibrating, and when another thing is the property of the medium, vibration requires elasticity because in order for something vibrate, you have to have a mass and a spring system. Mass spring system in order to keep the vibration can lasting. And then I explain, okay, we have no problem with mass, right? Now problem is now elasticity. So you said that elasticity, where does it come from elasticity, right? And actually elasticity arises from magnetism. I have a wonderful demonstration, but for now, I'm not going to demonstrate that part, maybe later on. And then
You
The
can
conclusion is
always, by the end, you can always supply me with any links you want, and I put it in the description of the video. All
oh,
your links you want, I can.
thank you.
You just send me by email your links and of other presentations or
Okay.
papers you have, and I will put them in the description of the stream later
Oh,
on.
thank you so much. And then I would say light. So basically, light wave needs a medium, and I just try to say the medium made by because of the wave is a magnetic medium, magnetic particles. Wave is a magnetic waves, right? So of course, the medium is made by magnetic particles, and the finalized the light is a magnetic oscillation. Oscillation is a magnetic particle oscillation, and then propagation through a medium of Uon universal particle, just magnetic particles. Okay, so that's what it is. And now double slit experiment. Emmanuel, I feel guilty. Do you want me to continue this pace, or we can stop at somewhere?
No. Please continue.
You want me to continue?
Trust me. No.
Okay.
I don't like to compress people. No, please continue your full presentation.
Okay.
Thank you.
Sure. So then I would just say, hey, the reason we have a wave particle duality, or we have this kind of quantum mechanics called wave particle duality, the quantum mechanics awareness, is all from two called central mystery of modern physics. The two experimental tests. One is called the double slit experiment. And since Emmanuel, you understand this one, so I'm gonna just explain this one briefly. One question about if we use light as a medium, as a source, of the source, okay? So when light is, since in this theory, say light is as a wave motion. So when light wave goes through the two slits, these waves will be interact called coherent interact or constructive interference. So then create the zebra type of pattern in the background, right, in the screen. So that's called the interference pattern. So if light is a wave goes through two slits, will interference each other, no problem. So this is not the question. But what comes, the problem is when you have an observer turned on. So if you look at it, there's an observer detector. I make it looks like a camera lens or the eye, human eyes. When you try to observe which slide, the light wave, of course they said, hey, if you like wave, doesn't work if we lump the light particle one at a time, right? So observe which particle, light particle goes through the slits. They turn off another detector. What happens when you turn on another detector? You have another wave called the light wave, which is not the same. Is not the same light source from the original light source. So it will have a different phase, different amplitude, and different wave propagation direction. So what happens? It destroys the original, the interference pattern. So when you destroy the original interference pattern, what happens? So all the light particles end up on the back screen as two concentrated lines. No other lines, only two concentrated lines parallel to the two slits. So this is about the light as a source and the problem. But this is so easy, so natural. But what I try to explain, the most difficult part of this one is what happens if we're shooting on electrons. We know electrons are individual particles, right? In this theory, electrons are actually magnetic particles, okay? So let's say if we're shooting electron and we're shooting electron one at a time, that's where we find it's very strange. So if we're shooting one electron at a time, gradually, the pattern on the back screen will be still like just a light interference screen. just like the screen showing now. So that people puzzled. So how could you shooting electron one at a time? So then there is no two waves interaction, right? It's only one at a time. How could one particle interact with itself? Say like a electron shooting one at a time, but somehow appears like an electron goes through both slits at the same time and then interference each other and come out of this pattern. So that's where come out of this called a quantum particle called wave and particle duality. This is and all other kind of strange phenomena. But let me just explain why this have nothing to do called wave particle duality. This is have everything to do with the electron that's a particle interact with this medium which we call the ether, right? Since this theory demands, say light is a wave propagates need a medium. So that's why when you're shooting electron, even one at a time, what happens? Electron carry magnetic field, right? So when electron moving in the medium is made by magnetic particles, right? The medium are electromagnetic medium, right? It's a magnetic medium. So when electron magnetic field interact with the medium field, what happens? Create self-generated wave. Just like somebody swimming in a pool. If you're swimming in a pool, you try to go through the slits. What happens? The water molecules,
Yes.
the water molecules around you also create a wave called the self-generating the wave.
I agree 100% with you, Dr. Yu, about this. I agree 100%.
Wow! So then you stop.
Yes, all the problems is because conventional modern science says there is no medium, and electromagnetic signals propagate without medium. As soon as you introduce a medium, all these problems are no problems anymore.
Yeah, all problems are solved, right? Such a simple thing.
Yeah.
So that's why we both end up with a single atom, a single particle.
Say for example, your photon or your electron is a small boat, and it passes through one slit of the two. But at the same time, it will create waves in this medium,
Right.
both of the slits, and then interfere in the back and make the interference pattern. It's so simple. So you see, the whole problem is because conventional science supports, does not endorse that there is a medium. That's all the problem. The Michelson-Morley example, it was a disaster. It was the wrong turn. The Michelson-Morley experiment.
Right.
Was,
Actually, they do not claim that there's no medium. Right.
Because they say they prove there is no medium for electron. That's wrong.
That's a false claim.
But
Yes.
you see now the modern physics are coming back to this idea with all this quantum form and all this 0-point energy.
Right.
Yeah, I mean, it's some kind like ether, but disguised modern times. That's all. But I agree 100% with you. If you accept
now
that
something now since turn around coming back. Yeah. Now it's coming back. All the evidence point we do see quantum fluctuation, right? 0-point energy, the so-called vacuum is all filled with energy, right?
Yeah, that's just another word for saying ether. That's all it is.
Right. Or simply say ether. Somehow.
The quantum vacuum. What do you mean the quantum vacuum?
Yeah, now we use ether to say, hey.
Type of energy which is quantized.
Right. You say vacuum. Actually, use vacuum represent the ether. People somehow accept it, right?
Exactly. Vacuum represents the ether. That's
yes. So it's all the semantics.
Yeah,
yes,
semantics. Even if they don't accept that, it's actually semantics. Yeah, that's all.
I'm so happy you give me real time feedback and also make me more understandable, deeper understanding of your theory.
I'm also very grateful for meeting you and having the opportunity, Dr. Yu, to speak with you and you present your theory. So please continue. Then I will make just a short presentation of my theory, and then we can discuss for 10 minutes or so and conclude.
Okay.
Yeah. So please.
Sure. I'm gonna. I can stop anywhere. I'm gonna just very quick. So if this one, if if you understand this one, then another one is a photoelastic effect. Do you want me to explain elastic effect, or we can skip this one?
I don't know. Well, yeah. If you can finish in the next 10 minutes, that's okay.
Okay. I will finish in next 10 minutes. So this is there's a Albert Einstein win Nobel Prize with this photoelastic effect, but I try to say, hey, why he can win Nobel Prize on this one? It has against some theories wrong, right? So I said, hey, before Albert Einstein, there's a classical theory talking about light is a wave and the electricity is a flow of electron, which is wrong, but light is a wave is correct. And when they interpreted this is called the photoelastic effect, is proportional to light intensity. What that means? That means, hey, if I ever use one light, does not create the electric flow, right? And then I put 10 lights or 100 lights. So increase the number of lights, you will increase the triple intensity, right? But we still do not see this. Do not see increase the intensity, generate the electricity.
You have to change the frequency for the
yes.
Effect.
That's where Albert Einstein kicked in. That's the middle one. He said, "Hey, we do not need to increase intensity. You do not use different multiple lights. We can just change the color of light, which means changing the frequency of the light, and which win Nobel Prize." And that's correct. However, in his interpretation, he has several wrong assumptions. One is the photon are particles of light, particles, and also assuming electricity is particles. So the particle impact particle have to knock electron on large electron from its atom, and then create the free electron to form electricity, which is wrong. But however, his final answer say, hey, if we change the color, use frequency, we can generate the electric effect. So that's why I make him win. And now I try to explain my Uon theory. Uon theory say, hey, light is a wave, it's a vibration, and electricity is also vibration, but it's just a vibration of the particles on the surface of a solar panel, a surface of the photoelastic material, right? Just like a solar panel. Mm-hmm. So when those two waves resonant, you create a coherent oscillation, right? Now you create electricity effect. So that's why. So I said, hey, the so-called photoelastic effect is not because light is a particle, is because light still is a wave, and the electron is not a particle either. Electron is a wave motion too. So that's called a resonance. So resonance is a light electron wave that create resonance. That's created this called photoelastic effect. So these two experiments is all misinterpreted by as a foundation of the quantum mechanics model. It's misinterpreted. So they create, wave can be a particle when you not look at it, and the particle can be a wave. So that's why from these two foundational experiments, I just say, hey, we can use a classical concept, use existing standard classical laws, explain this one without a problem. Okay, so from now on, I will not to do any more detailed experience, but I will, Emmanuel, I will go through quickly glance through what I have next one. So since I said quantum mechanics model is particle does not exist, quantum mechanics model out, and the light is not a particle, it's a wave. What happens? That means we bring ether back. Okay, so that means have a medium. And then the next one I will say, and by deeper study, what's the particles made up the medium of the light? So the smallest particle, what I find is actually the magnetic particles. So I'm not go through it. So that's called the Uon. Maybe just show you this one chart. The Uon is the only fundamental particle is a magnetic particle. So magnetic particles, that's made out of the entire universe. And let's see. Magnetic particles, and I wanted to see how to make a neutral particle. Not here. Maybe I skipped up. Yeah. So one thing about the magnetic particles, I wanted to make sure one thing I want to make a part special properties of magnetic particle. There's a unique property of magnetic particle. Magnetic particle, you can infinitely divide them geometrically or structurally. However, it still remain physical properties still carry negative and positive poles. So that's what magnets happens. You divide them, you always see negative, positive. And none of the quantum mechanical particle has this property, and then so that's why. So this is made magnetic particle as a one and a single fundamental particle. In the making universe, and actually. Emmanuel, I saw that you mentioned about what's it called? This is called the superluminal. What is the superluminal?
I will tell you a few words.
Yeah,
yes.
It still has. Yeah, it is still carries the same thing, right? Have a north and south charges. So very good. Okay, so at this moment, so I'm gonna skip this one, and then. I want to show you one important things. Say, if I say everything made by magnets, can we reproduce matters? Can we reduce all the chemical elements? So I use this is the only molecules, I find out on the internet that the most clearly, molecules I can find on internet. So if you look at the far left chart, and I use magnets, made all those molecules. If you look at it closely, they are identical. They match perfectly. And so this is a further confirmation of, say, the universe can be made by just one single particles, and the single particle can manifest all the complexity of the universe. So today I'm not gonna do this one because I want to I wanted to finish this one in few minutes, in 2 or 3 minutes. So, oh my goodness. Okay, there we go. Okay, so now let me see. The next one is about the gravity. So in this part, I justify how and why gravity is just the magnetic pole, just a magnetic attraction, which Emmanuel, I know you have that interpreting too. So I'm not gonna go through this detail. So I will justify why gravity is just part of a magnetic attraction force. And then the next chart is I tries based on all this.
Dr. Yu, this is we can now skip gravity. This is actually a matter for another discussion, because then we go too far. Just say a few words about gravity, and that's We can gravity.
I can just stop here. So gravity, when you understand everything made by magnets, then you will know gravity is just part of magnetic attraction, and all the forces can be eventually all arise from the fundamental magnetic force. That's the only force. So that's this one.
I agree. From all the forces can explain like magnetic interactions.
Yes.
You're right. I agree 100% with you, and this is also one of my points in my presentation.
Yes. And then finally, so all the general mysteries say when quantum mechanics we know that's incorrect because it is founded on wrong foundation, and then relativity. We know relativity is incorrect either because the so-called general relativity is talking about a gravitational effect, right? Gravity. Since gravity is a magnetic attraction, we do not need called geometric interpretation of curvature of space-time geometry. So we don't need this one. So, and then you go ahead.
It's not wrong. It's just an effective, another effective theory.
Yes.
Things, but it's
just a different interpretation. Use geometry.
It's not the most fundamental theory. It's an
that's right.
Theory.
But we do not need it. If you know that another interpretation, that's okay. But since
the most fundamental theory, according to me, is the one which is most close to the ontology of the things. The one which is this is the most fundamental. It's just another effective theory, like quantum mechanics.
That's a different interpretation.
All these effective theories. But you and I, we are not interested in this kind of effective theories. We don't play with toys. We want to say to the people, to the fellow scientists, the real ontological theory, to remind us of how old physics was done. Old physicists and scientists were very much concerned about the ontology of things, not just an effective model for making calculations. That's fine, that's great. But in order to progress and go to the next breakthrough, you have to understand ontological the theory. If you don't master what really is happening, the Occam razors, because if you don't understand the Occam razors truth, you cannot make a breakthrough and make science or Star Trek and warp speed and conquer the speed of light and go faster than the speed of light.
Yes, so, I agree with you, especially the Occam razor.
Our theories today came to a pivotal moment where we hit a wall. I mean, you cannot go forever effective theory, toy model. Yes. Sometimes you have to face reality. If you don't find what really is going on in the micro world, we will not explain even in the most cosmological scales what happened. So thank you very much for your presentation. I don't know if you want to add something more before I go to my presentation, which will be just 6 minutes. So do you want to add something more, something for last, for an epilogue?
Sure. I just show you my last page. Okay. My last page.
We can always continue with another session and present more things, more material.
Yes. We can always continue this one. The last page. There you go.
Okay.
Yeah.
I mean, for me, it's nothing new because I have seen all your presentations. I have seen all the slides, but it's only for to explain even more and for the audience.
So the last page is the theory of everything, just one fundamental particle, and can manifest the diverse of universe. Okay, I'm done. You take over, my friend.
Okay. So yes. So Dr. Weiping Yu, it was a wonderful presentation. I congratulate you really for your stress and easy explanations you have provided, which makes totally sense. Yes. And
thank you, my friend.
And so adding to this presentation, I will now make a very short core presentation of my basic ideas. Of course, my ideas also expand. Yes, my ideas also, as your presentation expands to many fields, but I will now limit myself only for this core idea of my theory, which is actually very complementary to Uon God particle.
Yes,
because
I agree.
I use also God particle, but with a different name. That's all.
Exactly.
You will see
different name, and I noticed you also ignored this. You also find something could be faster than speed of light. Is that right? So
yes. I will not talk this. Yeah. So okay.
I agree. Speed of light is not the limit of the universe. Okay.
Yes. Okay. Hold on. Share screen. Yeah, give me just a minute. Entire screen. This one. Share. Okay. And hide. Okay.
Okay,
So,
I can see it. Yeah.
so you can see probably my presentation as well.
Yes, I can see it. Yeah.
And you can see
General
both of
theory
our
of zero-point energy.
yes.
Beautiful.
Can you see is visible also both of our video cam feeds? Both of
Oh,
our faces are in the screen. Yeah. Yeah. Okay. So yeah, uh, my theory is actually similar to you. There is only one particle. Only I describe everything like electromagnetic flux. So
yes.
in my model, the whole universe is filled with some kind of vapor, which consists all matter and light. So all the elementary particles are some manifold, some energy flux manifold of this vapor. So you can imagine it like water. So you have water. Water, if it's still, you cannot. It's inert. You don't see anything. As soon you disturb water with your
Uh,
finger, you see some patterns, some vortices. So everything matter, all the elementary particles of the standard model, and all
okay.
the light and light particles are actually uh, flux manifolds inside this water volume. This this vacuum. So why we see the vacuum like empty? Because if it's undisturbed, it's like clear like water, so it's invisible and it's imperceptible. But as we start disturbing this vacuum, then we see the first fields, and the most common manifestation of a matter field is the field around the magnet. So here in this slide, can you see what is common in all these slides? This is this is an electric carrying wire, electric
Okay.
current wire.
Yeah.
This is a magnet. This is an electrical solenoid.
Right.
This is in my model the electron.
Oh, okay.
All these three, you see, all these three, the coil, the wire, or the coil, or the magnet, are not the magnet. The magnet is the field, is this flux here.
Yes,
The
it is a
magnet,
field. Yeah.
yeah, the magnet or the coil or the electric wire acts only like a disruptor of this vacuum energy, of this
Right.
energy which permeates everything, and matter elements are just manifolds of this flux. So this is what I call this not just electromagnetic flux. This is vacuum flux actually,
Okay.
vacuum flux, and each of these flux lines you can see. For example, if you sprinkle around the magnet iron filings, yes, of course
Right.
they are not just these lines. They are infinite lines of this flux of energy of this which is imagined like ether flux, or so each point of this here is one of your ions.
Yes. Yeah. You
Each
are
point
right.
of the flux line of
Yes.
this
Yes.
distorted universal ether medium, as soon you disturb it, it will create flux. So
Yes.
everything is manifolds of charge flux. It's a manifold of this vacuum flux, of this electromagnetic flux. So here in there is no single charge and monopole and magnetic on electric charge. There's only one kind of flux, this vacuum flux, which
Right.
creates this double joined back-to-back vortex. This is a
Yes.
type of vortex, and this now here. So all these have in common the flux, the vacuum flux, the field. The
Exactly.
field is the magnet, not the magnet itself. The magnet itself is just a disruptor of the vacuum energy, and
That's
the
right.
coil the same as to the wire. So the electron, which is here, this flux manifold, and each dot in the blue lines here is one of ions of these infinitesimal magnetic particles, which consist this magnetic medium You say it's ether or magnetic.
Yeah.
I say it's just vacuum energy. Yeah, it's a vacuum.
Yes.
So everything is
Okay.
made of this vacuum, but the vacuum, if you leave it, it's incoherent. It's randomized. All the particles, these ions are random, and you don't feel it like magnetic. That's why you don't feel empty space as being magnetic. But as soon you make a coherent pattern, a coherent flux pattern of this, then
Right.
you create a field. So the
Yeah.
electron is actually just a dipole magnet. It's the quantum magnet. It's the ultimate
Exactly.
quantum magnet. Yes. So each of these dots here, each line of these flux lines, each dot is one of your ions. Well, I
Yes.
call it a different name, but
Right.
let's say it's one of your ions. So here, the only difference is the electron has actually a physical rotation, a spin. It's not just the angular momentum we can measure in the electron. It's
Right.
actually due a real physical spin. So the whole thing now, it's rotating. And there is no electric charge and magnetic moment. There's just electromagnetic flux. And please be careful now what my point here. The flux going inside and creating this flux tube is actually what we call magnetic moment. This magnetism. All the flux around here, the sphere, is what we call electric charge. But these are just semantics. In my theory of the charge flux model of the electron, there's only this vacuum flux, and this back-to-back dipole vortex of energy of vacuum flux is creating both the magnetic moment and also on the surface in a 90-degree angle, you have the electric charge. So all the
Yes.
flux, all the ions a stream of ions. You can imagine like a dipole vortex of ions, of all this flux going inside in this line here, this flux tube is creating the magnetic moment of the electron. And not just
Right.
for the electron, but for all charged fermions, actually, for all spin half fermions. And all the lines here around on the sphere, and this horn torus formation, this formation in geometry, it's called horn torus. It's actually a spheroid, a horn spheroid. All this stream of ions around in this surface is what we call the electric charge. But the magnetic
Yes.
moment, the magnetism of the particle, of the electron particle, is created by this straight flux now here. This straight flow of ions, particles, magnetic particles, will create the magnetic moment.
Right.
So now, it's something very important. I have proved in my theory that you can read that in my publication here
Yeah.
at the bottom. That there is a very important factor. We call it the fine structure constant of
Okay.
the electromagnetic force, which is approximately one. It's a dimensionless number, and it's approximately 1/137. Yeah.
Yeah.
This exactly is correlated with the force of the electromagnetic force.
Okay.
So
Yeah.
I found in my theory that actually this is my novel theory, that this fine structure constant is actually a geometric proportionality constant of this charge flux manifold. So and particularly this flux tube here, if imagined like a straw. So the diameter of this straw is 137 times smaller than the diameter of the whole, than the radius of the whole here, a charge flux manifold of the electron. So if you go back,
Yeah.
yes, if you go back, sorry. So this straw here, this flux tube, has a radius. This radius is 137 times smaller than the whole radius of this charge flux manifold of the electron, because in my theory, the electron is nothing solid. This is the electron. This flux manifold, because as I explained before, the magnetism comes not from the magnet. The magnet is just a disruptor, is the cause. the magnetic field is which creates the magnetic effect. So the charge it's logical to say that there's no corpuscle inside here in the center. But the electron charge is just this charge flux manifold, yeah?
Yeah.
And when we have now an atom, a hydrogen atom, then the hydrogen atom is here in the center. The nucleus is here in the center,
Yeah.
and the Bohr radius or the Bohr electrons is just this electron. So the electron is not just a dimensionless point. It's a whole manifold of flux. So everything is made out of this vacuum flux. Everything
Okay.
is made up from this electromagnetic vacuum flux. It's nothing new. Even the charge, because they say, but we never know what the charge is. What is the charge of what is the substance which makes up the charge of the electron? And I say, no, it's nothing magical. It's nothing new. It's the same thing. The charge of the electron is made out of electromagnetic flux, of magnetic flux, of this stream.
Exactly.
Yes.
Yes.
That's all it is. So you have your universal magnetic medium, the ether, the Uon sea of particles, and when you distort with any distortion of this universal fluid, yes, it then manifests like flux, and we know that from like magnetic and electric flux. And please also something I want to emphasize here: electric flux is nothing different from magnetic flux.
Exactly.
Only magnetic flux has a curl. It must return back from north to south.
That's right.
Electric flux terminates straight to the other charge, but it doesn't mean. But the substance is the same. The substance is a stream of ions. In every line of flux, you have this universal particles, this magnetic infinitesimal God particles, the ions. So all the flux.
Yes.
Everything is made out of ions.
It works. It works.
Yes. Yeah. So now, please, I will tell you something that will astonish you. So here, okay, the electromagnetic force is dictated by the fine structure constant of the electron, which is 1/137.
Right.
But the strong force, they always say, no. Strong force cannot be electromagnetic, cannot be magnetic, cannot be. No. Yes, but let's now see that from the perspective of the flux energy, not just dipole magnetism and charge.
Right. Yeah.
Let's make everything flux now.
Right.
Everything consists of
Flux.
a stream of a flux of ions. Now, the most fundamental level, besides the Uon particle itself, is this flux. Everything is made out of flux. Yes, everything, matter and light. I will prove that now.
Right.
So the strong force has a fine structural constant of 1. Now let's make a logical experiment together. If in the electron the fine structural constant, the coupling constant, is 1/137, which in my theory translates that this radius is 137 times smaller than the whole radius here, the radius of the straw here of this flux tube is 137 times smaller than the radius of the whole sphere, of the whole magnetosphere of the electron, right? Yes. So now,
okay.
Yes. Is this clear? This is my theory.
Okay.
And I've proved that analytically. That the fine structural constant is a geometric proportionality constant, and for the electron, it's this radius is radius here at the center where the straw is 137 times smaller, approximately, than the radius of the whole charge sphere of the electron. Yeah. So what we say, what the conventional physics says and have measured for the strong force, which
you quantified it. Yeah.
They say that the strong force is not a magnetic force. It cannot be. I will prove that this is wrong. There's only one force actually, and it's the magnetic force, or whatever you call it, electromagnetic. Everything is made from electromagnetic flux. I will now prove that to you. So we know that in the strong force, the fine structural constant is 1.
Right.
Okay, let's take this number. What happens when we make the radius of this spiral sphere. This is a spiraling sphere. Yeah, it has imprinted spirals in it. So
Right.
if you make one the radius of this here, this large radius with this radius, so this now the denominator becomes the same. Yes.
Mhm.
What happens to the shape? What will happen to the shape? It will become a solenoid, a spiral. So now a spiral of ions, a spiral of vacuum flux,
Right.
is a quark. This is a quark.
Okay.
As soon you say that the fine structure constant of the strong force is 1 and not 1 over 137, then you have to equalize this radius with this radius. So what creates this? This creates a spiral solenoid. Yeah,
Mhm.
this exactly is what this spiral of it's not just a flux tube, it's a spiral, it's a spiral flux solenoid. This exactly now behaves as this conventional physics says the strong force behaves. So if you leave it if you leave the this spring now to its normal natural size, it keeps okay. If you try to expand it, as the strong force, it will strongly object and attract back. It's elasticity. And this
Yeah.
is going, they have measured that for 1 to 2 femtometers. For 1 to for 1 to 2 femtometer distance of one nuclear a proton to a neutron, for example, the
Okay.
force becomes very attractive. You cannot take it apart. And they say when you now compress the spring beyond less than half femtometer, 1 femtometer is minus 15 power of 10 meters. Yes, that's a femtometer. When you now compress this in the strong force beyond this point, this 0.5 femtometers, then the force becomes repulsive. But this is exactly what a mechanical spring does. In its natural not sides, when you try to expand it, it will attract back. And when you try to contract it more, to compress it, it will repulse. It will how you call it, react to it. It will try not to compress it. Yeah. So
Right.
if you do the electromagnetic flux, as they say, if you translate it from 1 to over 137, which is the fine structure constant of the electron, if you make it back and to make it now 1, this means that this whole spiral spheroid becomes a solenoid, a spiral, a spring actually. And
Oh.
this now
Okay.
is the strong force. So I have now proven that fundamentally everything is magnetic flux.
Yes.
Everything is made from this is manifolds, distinct manifolds. All the elementary particles, they say, of the standard model are actually um, uh, distinct flux manifolds of this what we call vacuum zero-point energy, or
Yeah.
what, according to Dr. Weiping Yu, a stream of his elementary particle, which is the only elementary particle, the Uon. Yeah. So eventually, everything is there's only one particle. This makes streams of flux, of vacuum flux, electromagnetic flux, magnetic, call it whatever
Yeah.
you want. And on these different distinct manifolds of this flux, of this vacuum muon flux, is the elementary particles of the standard model, whatever you want to make
Right.
it. Yeah. So this now is a quark. And why a quark cannot be found alone? Why? Because you see here the manifold is not a dipole. Here you have a curved manifold. It comes back from North Pole to South Pole. Yeah,
Right. You have to
comes back,
close
comes
this.
back.
Yeah.
But a quark, they say, you cannot find never an isolated quark. Of course, you cannot find because it's an open-ended flux manifold. You have always to connect a quark with another quark. So you have
Right.
2 up quarks and 1 down quark, you make a proton. If you have 2
Oh.
up
Okay.
quarks and with 1 up quark and connect it in a triangle, you make down quark. Yeah,
Right.
that's all. So you have here the three flavors of the 2/3 charge fermions, the quark fermions, and this is a 1/3 fermions quarks.
Right.
So the only difference here the spiral are more condensed per volume space. There are more spirals of flux. The 1/3 charge, they're more, they are more spare here. The one spiral from the other, the one spiral from the other are more spare, and of course, more distant. And of course, the whole thing spins because even quarks have angular momentum. So
Right.
the electron spins, rotates, has a physical spin, and also the quark has here a rotation, a physical rotation. So I will now end. So what is a photon now? Exactly like you. So you have this medium, this magnetic medium, yeah? This magnetic medium.
Yes.
As long it's not disturbed, it's not disturbed. You
Right.
cannot see it. That's why also we perceive empty space in the outer space. Star Trek or Star. You cannot feel a space because it's homogeneous and everywhere, and you cannot feel any magnetic attraction if you go to outer free space. But as long at the moment you disturb it, and how you disturb this medium? With a magnet, with an electron, I don't know what, with a discharge, with a spark, whatever. As soon you disturb this electron, then you create patterns, manifolds of this flux. This actually is a flux. It's a ether flux. It's it's the non-magnetic flux. So of course, a photon has no electric and magnetic charge separate.
Right.
This is because it has a spin 1. So what means in my theory spin half? It means that it has a magnetic moment, has this vertical here flux tube. This makes it a 3D volume particle when it has mass and has a spin, a magnetic moment. A photon has no electric charge, but it has an electromagnetic charge. Yeah.
Right.
So what is the electromagnetic charge? The electromagnetic charge of the electron is this flux here, this flow of Uon's particle around. This is the electromagnetic charge of the photon. And what is now the photon? So the photon, in my theory, is exactly where the source of the vibration inside the ether medium. Exactly here.
Disturbance. Yeah.
Yeah. If you measure here the perimeter of the finger, of the first imprint the finger makes, this perimeter is the wavelength of the photon.
Yeah.
Now,
okay. You define wavelength. Yes. Yeah.
This now creates propagating outer rings, which are propagating outwards. Yes.
Right.
But this is very fundamental because this perimeter here is actually correlated with this distance here, because the distance between the two waves is the wavelength. So if you measure, in my theory, if you measure the perimeter here of the photon, it's actually the distance between the
matches that.
Matches it, and this is actually what we call wavelength. The distance between the two waves is the wavelength in light. Yeah, and the number of waves passing from a point in space we call frequency. But this is very fundamental. The photon, yes, you cannot say it's a particle, but it's the initial disturbance. The initial is actually the imprint of the finger here. The imprint creates the first distortions. The perimeter of this distortion is actually the same with the distance between the waves. It's
that's the wavelengths.
Yeah. So you can say that this is here the photon, and this the consecutive wave the photon creates is the light. So you have you can say it's a photon. You can say now you have a photon light photon particle wave duality in some sense, but it's actually only waves.
Yes.
So when you have now this here, this photon passing through the double slit, of course it's not just alone. You have all space, a space not empty. It's filled with ether. It's filled with magnetic particles of Dr. Yu. It's filled with Uons. With this magnetic. So of course, of course, let's say now that this translates also, this photon translates somehow.
Yes.
Of course, it will pass just one from the two slits, but all the waves will pass, all the wave of this matter waves of this medium will pass from both slits, and then will back interfere. It will interfere back.
Exactly.
And then when they hit the screen, the detector screen, of course you will see interference pattern.
Exactly.
And this waves here, if we say now that this is an electron, I believe it's like similar like the pilot wave, because let's say now we have a central particle here. This actually is, imagine like a small boat without a machine and without sails. The waves it creates when passing one of the two slits will push back or some kind steer the particle to the detector screen. So you get both. You get the wave function, which is this the wave interference pattern you get from this universal medium, but you get also the landing of this point in one of these places. So you get both. You get, because the question also Dr. Yu asked, what happens when you fire one electron? You can see in the detector screen individual electrons, but as you leave time to evolve, you will see again the interference pattern. So my answer to this is both the particle and both the waves land on the screen. You have in the same time the interference pattern and and actually the particles is steered by these waves. They're steered, and its final point, it lands, and you see it on the detector screen like a point. Is actually it was guided from all the interference waves from the medium, from the ether medium. So you have both the wave function and the particle.
Yes,
that's all.
That's right.
I was also very troubled about what you said when you have an observer. But then I discovered the truth, what really happens. Are you prepared what really happens? It's a technical problem. So what they say, when you observe, then the interference is destroyed. Yeah, that's what they say. You have only two slits. You have only two in the detector screen. You have only two strips. Yeah, that's what they say. Yeah, but there's a technical a technical detail they don't say. They don't do that intentionally. But I will now say what the problem is. When they say they now we put detectors, do you know what they mean? They put two photo detectors exactly behind the two slits.
Oh, okay. Yeah.
This destroys the whole space. So now the interference pattern, the interference has no space to act. It's
Right. Okay.
behind each slot. Of course, you will get only two strips then.
Right.
Because you destroy the whole space.
Very similar.
You don't give the waves the space to evolve and to interfere to each other together. That's a problem. It's a technical problem.
It's not difficult, right? So my goodness.
Yes, please, Doctor, you check this out. They do. I couldn't believe what they were doing. They just put two photo detectors just behind adjunct to each slit, two machines, two boxes, and all the space in between the slits and the detector screen is destroyed. There's no more space. So there's no more time for the interference pattern to evolve.
Oh, okay. That I see.
What happens.
Yeah,
it's a technical detail. I couldn't believe what I was hearing, what I was reading. So they put exactly behind the slits two photo detectors. This is what we mean the observer. Yeah, the observer is the measuring machine. But so they don't measure the effect on the screen 1 meter away the slits. They measure it just a few centimeters behind the slit. So there's no more place to the waves to interfere, to make the interference pattern. That's why they destroy the wave function and just see two strips whenever they observe.
Okay.
And you put now out these detectors from the slits, when you take them apart and just leave now the normal experiment, the two slits with 2 meters away the photodetector. So you have now the space in between, so that the waves can evolve. Then of course you see again, you see again the interference pattern. So this is spongus. This is just a technical problem. This has nothing to do.
Yes,
Yeah,
yes.
this is it's just. I want to say this about this because it was very important. So yes, I finish now. So my particle, my Uon particle, let's say,
Okay.
which consists this stream of flux, of vacuum flux, electromagnetic flux, whatever you call it, which makes up all the elementary particles, which means all matter and all light. Which this is the elementary particles of a standard model. Describe allegedly all the fundamental particles, which consist matter, solid matter, fluids, vapor, and also light itself.
Right.
So you have the bosons for light, and you have the fermions for matter. So I say everything is made from this flux, yes, from this vacuum flux, which
Yeah.
is a stream of. It's quantized, and the God particle is Uon, and in my case, it's the superluminal vacuum graviton. So what is? So you need one particle. I agree with you. In order to make a theory of everything, you need one particle. You cannot do one theory of everything with two particles. It's not possible because you
Yeah.
have to unify all known four forces in this one particle. So all of the four forces, the strong force, the nuclear, the magnetic force, who, by the way, are the same force. It's all magnetic. It's just
Exactly. Yeah.
different facets of the same force. It's all magnetic. And but anyway, let's say there are different forces now. You have to all these forces, including gravity, must stem out from this simple particle. Do you agree?
Uh-huh.
So, in order to have a theory of everything, you need one particle.
Yes.
One particle.
This is
My
a
particle is
yeah.
I call
This
it,
is the ultimate simplicity. Yes.
yes. This is Hakam Razor. Yes. So now my particle, I call it it's a graviton. It's a spin 2 graviton. I have developed the whole theory. You can
Yeah.
read it. Here are the references, and
Okay.
even more at the end of my presentation. So what is this? So all this particle, all this matter and light, as you said, in a closed system, it cannot be perpetual motion. So why the electron has a lifetime of billions of years, or the proton? Why?
Mhm.
It doesn't make any sense. This energy, in my matter must be, in my theory, must be always refreshed, the energy. There must be a hidden source of energy, which however obeys the second law of thermodynamics. So you have a higher energy source, which from which energy flows to a supply of lower energy. And this supply is our space-time, is our luminal space-time, which is restricted by the speed of light. So all of our matter and light we see is luminal energy. It means it has a roof, it has a physical limit, which is the speed of light. But if we assume that there's a second hidden tank of energy, which supplies constantly our space-time, our luxons. Luxons is another word for luminal energy. So if we assume that there's another universe, another space-time that supplies constantly with energy our space-time reality, this tank of energy must be of higher energy. Why? Because the second law of thermodynamics. You cannot have something, energy must flow always from a higher level of energy to a lower. So I believe that this dark sector we call, and we see it as nothing, as vacuum, is actually superluminal energy, but not necessarily tachyonic. It just vibrates superluminally. It doesn't, it does, at the inert state, it does not translate although it can translate superluminal, but in the inert, at rest, in the inert state, it's just, it's all gravitons. But they're vibrating superluminally. They're not translating superluminal.
Yes.
Because we can see also that in 2017, the LIGO experiment measured actually the gravitational waves and the transverse waves, and they go with the speed of light. Of course, in the theory, I said that they are actually also longitudinal waves. We translate inside this condensate. I call this the ether or the Uon's fluid. I call it superluminal graviton condensate because it's all
Right.
gravitons. So these waves you can have inside this condensate, which is the vacuum. You can have also longitudinal waves, which these actually are superluminal, and the special conditions can go superluminal. So,
Okay.
but the waves, the gravitational waves is also transverse waves like the light, and these go, of course, with the speed of light. But you can have translation inside the dark sector superluminally. Yeah. So, but
Yeah.
this is a topic for another discussion. So, my God particle now is the graviton. Here, this energy here, you can even call it that these are Uons. You have like a ring of fire. You have a very fast rotation, much
Okay.
faster than the speed of light. So this is the vibration. This is what they call superluminal vibration. This rotation of Uon particles, superluminal Uon particles. You can call it. This is the dark energy. This is the
Okay.
dark. And I have calculated that this speed here is approximately 122 power of 10 times faster than the speed of light.
Wow.
So it's c times 10 over the power of 122. So it's very fast. It's so
Yeah.
because this superluminal energy does not produce mass. So that's why we see the vacuum as empty. It's not empty. It's full. It's a vacuum. Empty space is actually imagine like a superluminal material. It's a superluminal vibration energy.
Right.
And we cannot perceive this energy because it's superluminal. It's out of phase from our luminal phase reality.
Okay.
So superluminal, I have actually proved that the superluminal vibration cannot produce mass. That's why actually we perceive empty space like empty. But it's not.
Oh, okay.
It's the highest point. All the energy comes out of the vacuum in the form of 0.9. I will now explain this. So now you have this superluminal component, and this
Right.
this is the graviton is spin 2. Spin 1 actually means a circle, like the photon. Photon is spin 1. Photon
Okay.
spin 1 is a circle, yeah. Spin 2 is just a superluminal rotating circle. So it's like a flywheel which rotates at superluminal speed, much faster
Okay.
than the speed of light. That's spin 2. And actually, I have proven that mathematically, analytically. So, yeah. So all the spin 1 is a circle. That's actually the idea of the spin. And spin half is this torus stuff I have demonstrated previously with Electron. So this is a stable particle, and this evaporates, and the evaporation, it's like Hawking radiation. This evaporates. Can you see this vapor here? This halo.
Right.
So this here is the evaporation product of this superluminal vibration of this, and this evaporation, this halo, this vapor, is this which fills all space. Is this Uons? This Uon sea, the sea of Uons, which permeates all space, according
Right.
to Dr. Yu. So this energy is Lorentz invariant. So each point in this vapor is one Uon.
Okay. Thank you.
Why every year our universe expands like a balloon? Because in my theory, you see what the problem is. The problem is, yes, it expands, but the density of the vacuum energy is always stable. They have actually measured the vacuum density. It's 10 minus 9, 10 joules per cubic meter. So it's power of minus 9, 10 joules per. It's actually equal approximately with the mass of one hydrogen atom in 1 cubic meter of empty space. That's the 0-point vacuum energy. And they measure this energy always constant. The density per vacuum, per cube of
Right.
vacuum. It's always, this means, what does this mean? That in order now the whole universe to expand, something must stem out from somewhere. There must be a constant supply of energy. Like, if you blow wind in a balloon, you're always supplying with constant wind the balloon, and the balloon expands. So from there comes this additional 0-point energy. So this gravitons, which makes this sea of superluminal graviton condensate are called, or a sea of muons, these gravitons constantly evaporate. It's like Hawking radiation. So they evaporate to this vapor, which vapor is made out of muons.
Yeah.
So it's like the muon changing phase now. You have the superluminal muon, which is now, and then it evaporates, it decays to a luminal, to a C speed. It's a Lorentz invariant. Here in the bright circle, you have the superluminal rotation of muons. These are very energetic. These are superluminal muons, and this phase transition to or evaporate to a luminal muons, the muons which obey the speed of light limit. Yes, and that's why actually we see all electricity and magnetism to propagate, and light to propagate with the speed of light, according to me. Yeah, according to me, of course. So now, but what we have now accomplished, we have accomplished very much, because we have actually, with this with this idea, unified 3 of the forces. We have unified.
Right.
If everything consists of this stream of flux of muons, everything is vacuum flux, everything is electromagnetic flux.
Right.
We have seen in the case of the manifold, of the charge manifold of the electron, or the charge manifold of the quark, like a flux spring. Yeah. Then we actually unified the 3 forces: electromagnetism, strong force, and weak force. Again, weak force are just, as also Dr. Yu has very much demonstrated in one of his demonstrations, when it's an electric gun, a magnetic gun, when one of the magnets comes with momentum and hits a row of magnets, the far left magnet will be expelled. So this kind of weak force. Do you remember, Dr. Yu, your demonstration? The weak force?
Yeah,
the weak force.
that's right. Yeah.
So you have, it's like a rail gun. You
Right.
have
Oh
magnet.
my goodness, you saw that
Yes,
one. Wow.
yes. Yeah, of course I've seen that. I studied very much your work. So what is the weak force? The weak force is spontaneous radiation of some matter materials. Yeah, it radiates beta radiation, which is electrons, or alpha radiations, which is helium atoms, and so on. So, but everything is made from flux. So if we can explain from what this flux, vacuum flux, stems out, these
Yes.
streams of muons, then we have actually proof that everything is comes out from this one particle, from this God particle, from the Uon, or
Yes.
my superluminal graviton. Yeah. But now gravity remains. Gravity is a problem. Of course, you can neutralize gravity. Of course, everything in his explanations, they are very good, and I suggest to everyone to seek for it, for the gravity explanation of Dr. Weiping Yu. Of course, you can have neutral charge matter by rearranging the magnets antiparallel. You destroy the magnetic field, but there is always a incoherent magnetic field around. So you can explain everything. But I want to go even deeper now with my model of the particle, because you need to explain that in the level of the particle you say that is the God particle.
Oh.
Now, I want now to
I saw
explain
that
this. Yes.
somebody
I think
already
it's how-
claimed the God particle as a Higgs particles, right?
Yes, the Higgs particle. Yeah, but Higgs particle in my theory, when the two beams collide, is just a statical imprint of a graviton. So
Oh.
when the two, in the LHC, when the two beam matter particles, protoparticles collide with 14 tera electron volt, they just make a static imprint of a photon, because this photon is going very fast, and for just a moment it loses momentum, the superluminal momentum. And this superluminal momentum is the Higgs particle. It's just a static imprint, which is not stable, actually. The Higgs is not stable. So it's just
it's not stable, right?
Of the superluminal graviton, yeah. You can say that it's just a static imprint of your Uon when the two they just the crush, and because of course your Uon vibrates, everything vibrates. Yeah, it could actually vibrate superluminal, and when the two beam collides, then they obtain a static snapshot for one moment of your Uon. You could say that as well. So that for me, the Higgs particle is not a good particle; it's a ghost particle. It's a ghost particle of the God particle. So imagine like we have in our religion, Orthodox, we have the God, Jesus, and the Holy Spirit. So imagine now the Higgs being the Holy Spirit of the God. It's the ghost. Okay, so that's folklore now. Let's continue. So where's gravity? So this halo here, this evaporation product of the superluminal dark energy, is actually the 0-point energy, which is whatever makes all the matter and light. Is the substance which makes everything, and it can be quantized in joules. Yeah, you can say that. Yeah. But where is gravity? I have to do that in one particle. I don't want to use magnets and antiparticles. I want to explain gravity in the manifold of my God particle. You see here at the center, it's not a black hole. You see here a total absence of energy.
Right. I agree. Yeah.
So now all the surrounding energy is trying to go inside. So the gravity is the absence of any type of energy.
Okay.
So you can have black holes without being a solid sun inside crushed in a very tiny space. You can have, because imagine now that there is a distortion, a defect in the vacuum of this graviton condensate, where you have a very high concentration of gravitons. A very high concentration of gravitons means there's also a very high concentration of this empty space of nothing. So the graviton integrates both for all the forces and gravity, but the gravity is not an energy, it's not a force, it's the absence of any type of energy. And all the surrounding energy is acting now like a negative pressure. It's trying to go inside. All the energy here, the surrounding, the 0-point energy, is going to go in, to implode inside.
Okay.
That's my theory. So when you have mass, when you have a matter object, you have a lot of gravitons. But a lot of gravitons, this here energy does not count. This is out of phase of our space-time. We count only the vacuum, the vapor here, the 0-point energy, and this here. This is called hyperspace. This is truly empty space. So now, if you have a lot of mass, a planet, a sun, you have, of course, a lot of 0-point energy. That's why the sun has a lot of charge, magnetic, electric, and so on. But you have also what? You have a lot of this empty space. Now you have also gravity, because all this matter energy tries to implode inside you just follow the second law of thermodynamics. All this energy, from higher energy, you try to jump to a lower state energy. So gravity is the absence of energy. That's all. And it's actually an emergent effect from the other electromagnetic forces, because now the forces, all this energy is trying to, according to the second law of thermodynamics, to go inward, where the absence of energy is. And this is gravity. Okay. So the more mass a thing has, and a planet, the more, of course, mass it has, because the mass is created from the 0-point energy. It's just only a coherent flux of 0-point energy. If the energy is like that, vapor, you cannot feel it. It's always homogeneous everywhere, and you feel it like nothing. when you now take this flow, this flux, and make it to a coherent stream of energy, like like the flux we have here, then this becomes matter. Then this is mass.
Yeah.
This is not mass. But in order, in my theory, to have mass, it must be 3D. It must occupy 3 Cartesian vectors, the whole Cartesian space. If the flux is just 2-dimensional, like here, then you don't have mass. So in order to have matter, you need to have a volume of flux. If you have only a surface of flux, then you don't have mass. That's why the photon has no mass. But every other particle which has volume has mass.
Yeah.
So you need the flux to occupy all 3 Cartesian vectors of space, x, y, z, in order to have a matter particle, a particle with a mass. So now, the more massive a planet or a sun is, the more zero-point energy. This, it's like a gradient of zero-point energy.
Mhm.
The more massive an object is, the more coherent, more pressurized ether it has. More pressurized ether, more
Right.
pressurized flux of these Uon particles. Yes, the universal particles. But, yes, but at the same time, it has even also more empty space. It's a paradox. The more graviton means also it has more of these holes. So that's why if it has much more mass, it will have also more gravity. So this particle here unifies all 4 forces. And this is my superluminous, my gold
Theory.
particle.
Wow.
But then I came across your theory, and I was very, very impressed and very happy, because maybe your particle is more fundamental than mine. And explain why. Because you say that this Uon particle is infinitesimal small. Because if you have a magnetic dipole, you can split it forever.
Right.
You will still have a magnetic particle. Yeah.
Yeah.
So here, for example, in my electron model, it's just a dipole vortex. If you split it, it will lose. It cannot be any more magnetic. It will not have, because then you have 2 separate vortices. You have
Right.
2 monopole. It cannot be any more magnetic. You cannot form. But as soon as the 2 vortices come back together and form this vortex tube, then it gets again magnetic.
Right. Yeah.
So, so my particle now, why your particle is more fundamental than mine? Because I say that I didn't know what this vapor consists of. Of course, yes, I say.
So
this is
now you can
part.
use Uon.
Yes.
Yeah.
I say this is my phone. Okay, but what is this vapor consist of? Or what is this ring here? This very highlighted, very bright fire ring here.
Right.
Well, each point of this ring, what is it? So that's so it cannot be fundamental, right?
Yeah.
I mean, it is a good particle. It's in the dark sector, which evaporates to the light sector, our sector. But I still had the problem. What are the H point of this? Because I believe in a particle. I mean, always a point is more fundamental than a line. Do you agree? So
Yes.
by shape, a point is always more fundamental than a line.
Of course.
So we say, of course, we say that everything is waves. Yes, I do. But you can quantize it in points. You can always draw a line with points. So more fundamental is. So I believe in the point. I believe in Newtonian physics that everything is actually the most fundamental level points.
Mhm.
So what are these points here? And now you come in and say, I say now that each of this vapor, each of this point in this vapor is actually Uons. And there are 2 phases of Uons. There is the superluminal Uons, which represent the points here in this very bright ring, this superluminal vibration ring. These are superluminal Uons, and they evaporate, they change phases, some kind of phase transition. They're slowing down, to this ether here, which again ions, but this time it's luminal ions. They have lost, according to the second law of thermodynamics,
Yeah.
they have lost their energy from superluminal, evaporated to our Luxon's luminal energy, where the c speed of limit applies. So now here is the domain of of Maxwell and let's say Bohr and Heisenberg and this vapor here and Einstein, but here is the superluminal, the dark sector, is the unknown physics. So I believe, yes, there is a superluminal domain of energy which refreshes all the time our universe. So the vapor here is our universe, which consists from 0-point energy, and this is refreshed all the time by the superluminal graviton, this superluminal vibration particle, fundamental gold particle. Yeah, and that's all. And this was my presentation. Sorry, I took a bit longer.
No, no problem. I'm glad.
Actually,
I'm glad that you can apply.
By you, Doctor. Yeah, I was actually inspired by you, Doctor. Yeah, and yeah, I finished now. I will stop now. How you stop?
Oh my goodness! I'm so happy. I'm so happy. You know,
Yes.
you can even merge my Uon with your theory and come out with the quantified, you know, the calculation. It's amazing. You know, I notice you are very productive, right, in published papers.
Yes, yes,
That's good for you.
I do my physics like a hobby. I mean,
you as a hobby.
Yeah.
You are still the employee, right, of your university, right?
Sorry?
No, you are still working as a research
Yes, I'm
fellow.
affiliated here in the university. Yeah. Department of Electronics.
Okay.
But let's finish. I want to stop my presentation.
Okay.
Yes. So we are again together. So yes, yeah, that was my presentation, and thank you very much. And I hope this was constructive and fruitful.
Thank you.
And I hope we meet together and make another.
Sure.
So I was very pleased to meet with Dr. Yu and share our ideas. And actually, I want to ask you some things, but I think it's time now. Has passed a lot. Yeah, I want to ask you one thing, actually, because there is a counter argument about the vacuum being a medium. And the problem, the argument comes from Einstein. So if you have a source in space, let's say, and it emits light, a spacecraft, which is going close to the speed of, not a decent fraction of the speed of light, say 70%. And you have to emit light, yes? Like the rings we have seen in the water, these rings. Yeah. According to Einstein, there is no compression in front of the rings of light, which are exactly in the front of the spacecraft, in the direction of travel. There is no Doppler effect because the speed of light is always absolute. So that this, according to Einstein, this proves that the vacuum cannot be a medium, because you know if you have sound. Yeah, that's what they say. If you have sound, you have a train. In the acoustic waves, you have a Doppler as the train moves, and at the same time emits waves. The waves in front of the train will be compressed because you have air. But this is not the case for the. Einstein says this is not the case for the light. The light, there's no compression. There's no. Of course, an observer entering inside the cone of light, as he moves, he will see Doppler shift. He will see different frequency of light as he moves inside light. But for the source, as the source moves and in the same time emits light, there is no compression of the wave light in front. they always fixed. The first ring, the second, they always fixed. And this a elastic medium. So I want to ask you what you have to say about this, because this actually this is a compelling argument. This is a compelling argument.
Compelling argument about the no double
about that electromagnetic signal does not need a medium to be propagated. So actually, what we call vacuum is a medium. Is not a medium. It's nothing.
Right. So
I do not. Argument.
Yeah. I do not believe this is called empty space without any medium, without any medium as mediate all the interactions. I believe that just false assumption. Just like you said, this what is the Molly? What is it? Markoulakis, what is the experiment, right? So they said, Markoulakis experiment. They say that experiment justified there is no ether. I believe that's misinterpreted that experiment too. So far,
you believe that there is actually compression in front of the light wave, but we cannot measure it. It's so slight, the compression, that we cannot measure it.
We may not enough able to measure the difference, right? But then not because we're absent of ether, because we have a limitation on our instrument, right?
Yes. So it's a technical problem. I'm actually in the same opinion with you, because if they say that the flux, the 0-point energy density is the mass of one hydrogen atom per cubic meter, you cannot measure this, even if it's the compression.
Right.
You cannot measure.
We do not have that accuracy. If you look at the accuracy of the instrument, you do not claim. They claim they can measure what is to the 14th digit point.
Yes.
If you look at the instrument, they may not even get the 2 or 3 points correct, right? So
it's a technical limitation. Yeah, it's not a fundamental. It's not a technical limitation. I believe that as well. Yeah.
Yes.
So
I'm so happy.
So
I'm so happy.
I'm just very happy. Have a nice rest of
nice afternoon for me, but nice evening for you, right? I don't.
Now my time is it's 30 minutes past 9 here in Crete, in the island of Crete. I'm from Crete.
Yes, I see.
Crete is the source of the Minoan civilization. It's just after the Egyptian civilization, you have the Minoan civilization. It's a Minotaur and all that stuff, and Mythos with a golden touch.
Yes. So anytime, if you,
Dr. Weiping Yu, I'm very happy meeting you and sharing our desk, and I believe we can continue our conversation.
Exactly. We can, from our work, I think we can changing the world. Yeah. So thank you for inviting me, and thank you for the confirmation.
Yes.
And we keep in contact.
It was my honor.
We both love it, right? Okay. So love what you do. Okay. And if you ever come to United States, come to visit me. You can stay with me. I can take you to Kennedy Space Center or Orlando. There's Disney World.
The same,
so, yeah.
The same if you come to Crete. The same if you come to Crete. Yeah. It's the same invitation if you come to Greece, Crete. Yeah. Okay. Thank you. Bye bye.
Say hello to your wife. Say sorry. Okay.